One of the goals of algebra is to give you a bunch of tools, a bunch of models, so you have something to use with real life data, to make predictions with real life data. So if you look at this, it says, when can linear models be used to represent real life data? Linear models, remember, are what we've been working with, and we have slope-intercept form, we have point-slope form, and we have our standard form. All of these represent linear models. Remember, linear means line. So if we were going to graph real life data, if it lies on a line, then it can be represented with one of these one of these models here. Let's look at an example here. It says the manager of a restaurant made the following table. So obviously this is from a while ago, but it says in 1991 the price per pound for fish was $3.75. Meat was $2.50. In 1993, the average price per pound was $4.25 and $2.70. Sorry, kind of got cut off there. It says which data are better modeled by a linear model. Linear means line. So if you were to take, let's say, the year and the fish, and you were to graph it, in 1991, you would see is $3.75. In 1993, $4.25. So I already went through and I kind of graphed this. Remember, on the bottom here represents the years, and over here along the side represents the average price. And in this case, this was for fish. Now we probably could draw a line to represent this data, a line of best fit. And it would be okay, except if you really look at this data, you can kind of see a curve with it. I wouldn't expect my next point to be over here. I kind of expect my next point to kind of be up over here. Okay, so you almost kind of see a curve to this line. Now, could we model this with a linear model? Yes, we could, but I think we're going to start seeing some type of curve come to it. Okay. So, although we could represent this with a linear model, I think there's a better model, which you'll learn later, called a quadratic model or an exponential model that would probably do better. Let's look at the meat prices. Let's say we wanted to graph the year and the average price per pound of meat. Okay, so again, this represents a year, and this is the average price per pound of meat. Now, if you look at this data, although it's not perfectly on a line, it almost seems like this data is better represented by a linear model. Okay? I would expect the next point to be somewhere over here. There's not really a curve or anything to it. So if you look at this, it seems like the average price of meat is better represented by a linear model. Our line of best fit fits it better. Okay? So if it says which data are better modeled by the linear model, I'm going to go with the meat. Okay. Again, a goal of algebra is just to use the models we've been given to deal with real life data. So far, we've dealt with linear models. That's these forms. In the future, we'll be dealing with models like quadratics and exponential. Linear models, though, when you graph them, you should see a linear trend. You should be able to draw a line of best fit.